Hi, thank you for watching my video and looking at my poster. My name is Melissa Staggs. I am a study director at Smithers. I work in our short-term aquatics group, which means I am a study director for studies with fish and algae, daphnids, mysids, oysters, and sometimes midge and hylella. I've been with Smithers for about 10 years now. I started out in our algae group. I spent 6 years there and then moved to our sediment group for a few years where I got to work with the sediment dwelling organisms. And now I've moved back to our short-term aquatic group. My poster that I'm going to show you today is on UVCBs and how it's difficult sometimes to create a dose response and a gradient because they're so highly insoluble, and the concentrations that are actually in solution are very consistent despite actually having a very wide range of nominal loading rates. So I'm going to share my poster now and point out some of the highlights. All right, let's see if I can get this to work. Here it is. So I wrote this poster along with a few of my coworkers, and the topic of the poster, as I mentioned, is challenges with aquatic ecotoxicology testing and analytical confirmation of poorly water-soluble UVCBs. As you can see here in big letters in the middle, what we found from our research is that preparing cereal dilutions from a single WAF stock may be a more appropriate option for some UVCBs. So the OECD Guideline 23 recommends that we actually prepare individual water accommodated fractions or WAF solutions. The reason for this is that the analytes in a UVCB may have differing solubilities. So the concern is that if you prepare a dilution of a single WAF, that you might not actually get a consistent recovery based on these differing solubilities. So we conducted a study with a UVCB that contained 3 major analytes. We prepared individual WAF solutions as recommended by the guideline at nominal loading rates of 0.1, 1, 10, and 100 milligram per liter. So consistent with the guideline, we mixed these solutions for approximately 24 hours with a very low stir, and we then separated the soluble fraction from the insoluble fraction. And the analytical recoveries, which you can see in this table here, are surprisingly consistent for each solution. So here we have an order of 4 magnitudes, so 0.1 all the way up to 100 milligram per liter. But each analyte is recovering at almost the exact same concentration, only about a factor of 3 difference between our lowest concentration and our highest concentration. So the trouble here is that if we're preparing solutions individually from a wide range of concentrations, and we're getting almost the exact same measured concentration, we're going to get this really flat dose response that you see here. So the trouble with this is that we can't actually determine a robust ECX value with this flat dose response here. So if we're seeing approximately 15% reduction across the board, determining our no effect level, or EC10, is nearly impossible. So because of this, we suggest for some UVCBs that we should actually prepare a single WAF stock and then prepare dilutions from that. Although it's not in line with what the guideline recommends, we have good data here to show that this is an appropriate course of action for some UVCBs. So it's really important to understand the materials, to do some of this upfront work to really understand your material and how it's going to act in the exposure system. And then when you do that, you have a strong case for submitting this data, even though it's not in exactly in line with what the guideline recommends. If you'd like to have some more information on this, please contact us at info.ers@smithers.com. That's the link down here. And I'm going to stop sharing my screen right now. And just say thank you again for watching, and please contact us if you have any questions. Bye.